Hi class. So I wanted to add a little discussion on using multiple strain gauges on a Wheatstone Bridge. Looking at this image, you can see here if we have just one strain gauge where R1 is located, then that is just our quarter bridge, and that doesn't really increase our sensitivity. It just acts like a normal strain gauge, Wheatstone Bridge, right? But now if we wanted to increase the output voltage, to increase our sensitivity, we could add more strain gauges to this Wheatstone Bridge, which will help us measure the strain at one location. And it's important to remember, I can't add 4 strain gauges in a single Wheatstone Bridge placed at 4 different locations on some specimen I'm measuring. If I wanted to use, let's say, a half bridge where I have 2 strain gauges on a Wheatstone Bridge, then I need to configure those 2 strain gauges such that they will measure the strain at the same location. If I want to strain in a different direction in a different location, I have to have a whole different Wheatstone Bridge circuit. So let's say we want to measure something in tension or torsion or bending. Where do we put these strain gauges on the device, and where do we put them on the Wheatstone Bridge? Which branches, which of these 4 branches can we select? So, here is this. If we can consider this circuit, we are measuring the difference in voltage between here and here using this differential buffer amplifier. If we redraw this circuit to look something like this, there's 2 possible paths for the current to go. We can go through R2 and R3, which is supposed to look like 3, or we can go through R1 and R4. And we're measuring the difference in voltage between here and here. Now, if we happen to make R1 our strain gauge, and we strain it in such a way, so let's put it on a specimen. We put our strain gauge on here and pull on it. The change in length will increase, so the strain will go up, which will make the resistance go up. So looking at the diagram on the right, if the resistance goes up, then the relative resistance of R1 to R4 should be bigger. So that is like, let me erase this here, making R1 bigger compared to R4, which now gives us a higher level of voltage on the left compared to the voltage on the right, which gives us our change in voltage. If we wanted to put another strain gauge on this bar, so let's say at the same cross section we're going to put a second strain gauge to measure that axial strain, then which resistor would we put it on? Well, if we put the resistance on R2, that second strain gauge, what that would do is also shift this resistance R2 downward, because it would change its relative resistance, and our change in voltage would be pretty much 0. So the 2 resistances, if we put the 2 strain gauges right here, they basically cancel each other out, which is obviously not what we want. So instead of canceling out, let's put the strain gauge on R3. So now that'll make R3 large and R2 small, So now we have double the change in voltage, hence twice the sensitivity. So now, in this case, we're going to want R1 to be a strain gauge and R3. So there's two places, or that would be a half bridge where we can put, you can double the sensitivity of the strain gauge, and where we could put our strain gauges in R1 and R3. Now let's change our problem a little bit. Now, instead of an axial load, let's make it a bending load. So if we're going to fix this side and apply a force such that we get a bending stress, we have a strain gauge R1 on top. That is going to again increase R1 relative to R4. So let's redraw this real quick. So we have R2 and R3 about the same. R1 is going to be large compared to R4. So here's our junction here. So R1 is larger compared to R4 because that's what's being strained, and it increases in strain. So hence we get plus and minus, and we get our change in voltage. Now if we want to make a half bridge, where do we put our strain gauge? Should we put it on R2 or R3? And where should we put it? If we put it on top, so right next to the strain gauge, this is also going to increase in strain, just like our previous example. So we're going to want to put it on R3, which will make R3 bigger compared to R2, which make even higher change in voltage. Now, we don't always want to do that. Sometimes we want to put the strain gauge on the bottom. So, if our R1 is larger than R4, and we want to put our strain gauge on the bottom, or on the underside of this beam that's bending, then we're not going to want to put it on R3. We'll want to put it on R2, because the strain gauge on the bottom is going to get a negative strain, which means the resistance is going to decrease. So if the resistance is going to decrease, then we'll want R2 to decrease, which means it'll be smaller relative to R3, which again gives us that change in voltage. So therefore, R2 will be our other strain gauge. So can you see here, depending on your problem, you can place strain gauges where you want to. You just have to keep in mind, is the strain gauge going to stretch, or is it going to compress? Is it going to elongate or shrink? So if it's going to elongate, the resistance will increase, and we want to keep in mind where we put that strain gauge. So, for example, if we keep this same example, but we want a full bridge, so we have all four, and we quadruple our sensitivity of a single strain gauge, then we're going to have two strain gauges on top, two strain gauges on bottom. You see, according to this diagram, if R1 gets bigger, we want R4 to get smaller. So R1 gets bigger, R4 to get smaller. We'll want R3 to get bigger and R2 to get smaller, which will make a larger change in voltage. So if that's the case, then our two strain gauges that are going to get larger are going to be on top. So we're going to have R1 and R3 on top. And then on the bottom, we're going to put our strain gauges that are going to compress. So we'll have R2 and R4. And hence that will quadruple the sensitivity of our strain measurement in comparison to using just a single quarter bridge strain gauge. I hope this helps.